All right, today we are diving into a topic that is a huge headache for so many people, just absolute chaos on the file servers. And we're going to see how a pretty cool piece of tech called Distributed File System, or DFS, can really tame that beast. So let's just start with a question I think we've all screamed at our computers at some point. You need a file, right? But where is it? Is it on the London server? That server in New York? Or maybe it's on some old box in Tokyo that no one's dared to touch for years. It just feels like your data is everywhere and nowhere all at once. And this just says it all, doesn't it? Every single one of these is a different server, a different share, a different path that you have to somehow keep straight in your head. It's confusing, it's messy, and for the IT folks, it's an absolute nightmare to manage. And this is exactly what we call file server chaos. And it's not just about annoying server names. It means if you're in New York trying to open a file from Tokyo, it's going to be slow. And worse, if one of those servers decides to go down, well, work just grinds to a halt for a whole lot of people. But what if there was a better way? What if you only had to know one name, one single, simple path to get to all the company's shared files, no matter what server they actually lived on? And this, right here, is the magic trick of DFS. It takes all of those complicated, ugly server paths and tucks them neatly behind one clean, logical name. It takes the many and it makes them one. It's simple, it's elegant, and it's incredibly powerful. So how on earth does it do this? Well, it's not really magic. It's actually a team effort between two different but related technologies. A good way to think about it is like a map that shows you where to go and a powerful engine that makes sure everything's ready when you get there. Okay, this slide really breaks it down perfectly. On the left, we've got the map, DFS namespace, or DFSN. Its only job is to create that one single, simple view, that www.contoso.public address. Then on the right, you've got the engine, DFS replication, or DFSR. This is the workhorse. Its job is to constantly run in the background, copying files between the servers to make sure they all match. Let's look a little closer at that map, the DFS namespace. Think of it as a virtual folder tree made of smart shortcuts. When you click on a folder in the namespace, you're not actually going to a folder on that server. Instead, DFS says, you want that folder? Okay. And it seamlessly points you to the real shared folder, which could be on a completely different server, maybe even in another country. And then there's the engine, DFS replication. Its mission is to keep the files in all those real folders perfectly in sync. And the secret to its success is being incredibly efficient. It uses something called remote differential compression, or RDC. So what does that mean? Well, if you have a huge 100-page report and you just fix one typo, it doesn't send the whole giant file again. Nope, it just sends that tiny little changed piece, which saves a massive amount of bandwidth. So we have this virtual map and this super efficient sync engine. When you put them together, you start to see some amazing real-world benefits that make your file access way faster and a whole lot safer. Let's just imagine for a second. You're working, everything's fine, and then bam, the main file server in the London office just goes dark. It's completely offline. Now, in the old world, this is a full-blown crisis, right? The help desk phones are exploding, nobody can get their files, work just stops. But with DFS, nothing. For the users, literally nothing happens. Without you even knowing it, your computer is instantly and automatically rerouted to a perfect copy of that data on another server, maybe the one in New York. You just keep working. That's what we call high availability. So how does your computer know where to go? It's all about this referral process. When you ask for a file, DFS gives your computer an ordered list of all the servers that have a copy. And here's the clever part. It talks to Active Directory to figure out which server is physically closest to you in your local site. And it puts that one right at the top of the list. So you always get the fastest connection and the others are just waiting in the wings as backups. So let's just quickly run through the big wins. You get high availability, because if a server dies, no one cares. You get location transparency, one name to remember, that's it. You get faster access because you're always talking to your local server first. It's super WAN friendly thanks to that smart RDC sync. And for IT, it's a dream come true because you manage everything from one place. Now, as great as this all sounds,
DFS is not a magic wand you can wave at every problem. It's a specialized tool that follows some very specific rules, and it's absolutely crucial to know what it's good at and what it's really, really not good at.
This chart tells the story perfectly. DFS is fantastic for your typical office files, Word docs, Excel sheets, presentations. It's amazing for making those kinds of file shares highly available. But, and this is a big one, it is a terrible idea for things like live databases or running virtual machine files. Why? Because DFS replication can only copy a file after it's been closed, and files like databases, they're never closed. They're always open, always changing. And this brings us to the single most important rule of all. If you remember one thing, please let it be this. DFS is not a backup. It replicates every change. So if a user accidentally deletes a critical folder, guess what? DFS will happily delete that folder from every other server too. If a computer gets ransomware and a file gets encrypted, DFS will diligently replicate that encrypted file everywhere. You absolutely still need your normal backups. At the end of the day, DFS is an incredibly powerful tool for hiding complexity. It gives us this one clean, logical view of our data, even when it's physically scattered across the globe. And that kind of leaves us with a bigger question, doesn't it? As our data gets spread out even more into the cloud, onto edge devices, is this idea of a single virtual namespace the only sane way we're going to manage all of our data in the future?